Download this code from codegive.com, link in the description below. Understanding and resolving path conflicts with angle-based Apple developer forums, hypothetical. Let's dive into a complex, albeit hypothetical, scenario, dealing with path conflicts when integrating an angle-based Apple developer forums component, which we'll call AAF, into your iOS application. This is a theoretical exercise since angle-based Apple developer forums isn't a real library, but it's structured to mimic common path collision issues encountered when using third-party libraries, especially those with outdated dependencies or overlapping file structures. The problem: path conflicts. Path conflicts occur when two or more libraries or modules within your project attempt to use the same file path. This can lead to compile time errors. The compiler might find duplicate definitions, leading to errors like duplicate interface definition or redefinition of struct. Link time errors. The linker might be confused about which version of a symbol to use, resulting in unresolved symbols or unexpected runtime behavior. Runtime crashes. The application might load the wrong resources or execute unintended code. Why path conflicts happen, in our hypothetical AAF scenario. Let's imagine our AAF component suffers from the following potential issues. 1. Bundled dependencies. The AAF framework bundles its own outdated version of a popular library, example JSONKit, reachability, or even a custom networking library. Your project might already be using a newer version of the same library. 2. Asset conflicts. AAF includes images or other resources that have the same names as assets already present in your project. 3. Category conflicts. AAF uses categories on standard foundation classes, example NSString, NSArray, that conflict with categories you've defined or that are included by other libraries. 4. Header file overlap. AAF and another library, or even your own code, might declare a class or struct with the same name in a common header file directory, example a common utilities.h file. Example scenario: conflicting reachability libraries. Let's say your project uses a modern version of reachability.swift, but AAF includes an older, Objective-C version, reachability.h, reachability.m, within its framework bundle. Code snippet demonstrating the conflict. The collision. When you try to build, the compiler might encounter errors like redefinition of reachability, incompatible type for argument 1 of reachability with hostname, if AAF's reachability API differs. Strategies for resolving path conflicts. Here's a comprehensive guide to dealing with path conflicts, illustrated with code examples and specific techniques applicable to our hypothetical AAF scenario. 1. Dependency analysis and removal, best practice. Identify the conflict. Carefully examine compiler errors and linker warnings. Understand which files are colliding and where they originate. Use OTool on the compiled framework to explore included libraries. This command lists the dynamic libraries that AAF links against. If you see reachability or another conflicting library listed, that confirms the issue. Attempt removal. If AAF uses reachability internally, and you don't need AAF's networking functionality, or if you can replace it with your own using your existing reachability library, try to remove the embedded reachability from AAF. Framework modification, dangerous, not recommended for production. This involves modifying the AAF.framework directly. You could try deleting the reachability.h and reachability.m files inside the AAF.framework directory, in the Finder, then rebuild. This is extremely fragile and will break when you update AAF. Avoid this if possible. Asterisk rebuild AAF, ideal, but requires source code. If you have the source code for AAF, unlikely if it's a closed source framework. The best solution is to modify the AAF source code itself to not include its own reachability. Instead, adapt AAF to use a reachability instance provided externally by the application. This is the correct architectural solution. It's called dependency injection. Asterisk code example, hypothetical, AAF source code modification. Then, in your main application, 2 module mapping and umbrella headers, for Objective-C frameworks. Asterisk create a module map. Asterisk if you cannot modify AAF, you can try creating a module map for AAF to control how its headers are exposed. A module map, module.modulamap, tells the compiler which headers are part of a module. Asterisk modify the module map, if possible. If AAF already has a module.modulamap, you might be able to exclude the conflicting headers. This is risky and requires careful understanding of AAF's internal structure. Asterisk example module.modulamap, hypothetical, to exclude reachability.h. Place this module.modulamap in the same directory as AAF.framework. This tells the compiler, the AAF module consists of the AAF.h umbrella header, except for reachability.h. Then, make sure your project's build settings have defines module set to yes for AAF. Also, make sure the module map path is correctly configured. 3 header search path manipulation, less recommended, fragile. Asterisk project build settings. Asterisk in your Xcode project's build settings, you can modify the header search paths to control the order in which the compiler searches for header files. Asterisk prioritize your headers. Asterisk try to ensure that your header directories, where your reachability.h isn't being used, are listed before the directory where AAF's embedded reachability.h resides. Asterisk caveats. Asterisk this approach is fragile and can break unexpectedly if the build environment changes. It's generally better to address the underlying dependency conflict directly. Also, Xcode can be unpredictable with how it resolves header paths, especially with frameworks and modules. This can be particularly tricky with Swift/Objective-C mixed projects. For prefix header, discouraged. Asterisk add conditional compilation. Asterisk you could try to use a prefix header, .pch file, with conditional compilation, if and def guards, to prevent the older reachability.h from being included. This is strongly discouraged because prefix headers are deprecated and can lead to hard-to-debug issues. Use modularization and proper dependency management instead. Asterisk example, do not use this in modern projects. Then, in AAF reachability wrapper.m, if you could modify it. This approach is hacky and unreliable. Avoid it. 5. Renaming, last resort, risky. Asterisk if absolutely necessary. Asterisk as a last resort, you could consider renaming the conflicting files within the AAF.framework. For example, rename reachability.h to AAF reachability.h and modify the AAF source code to reflect the new name. This is extremely fragile and will likely break AAF if it relies on specific file names. You will have to manually reapply these changes every time you update AAF. This is highly discouraged unless you have no other option. Code example, hypothetical, last resort, renaming inside AAF.framework. 1. Rename the files asterisk. Asterisk in the Finder, navigate to AAF.framework-headers. Asterisk rename reachability.h to AAF reachability.h and reachability.m to AAF reachability.m. 2. Modify AAF reachability wrapper.m, inside the AAF framework. Remember to clean and rebuild your project after making these changes. Important considerations ****. Framework updates ***. Any manual modifications you make to the AAF.framework, renaming, deleting files, etc., will be lost when you update the framework. You'll need to reapply these changes after each update, which is a maintenance nightmare. This is why modifying the source code directly is the preferred approach. Swift packages and CocoaPods ***. Use Swift Package Manager, SPM, or CocoaPods to manage your dependencies whenever possible. They help with versioning and conflict resolution. Namespaces ***. Consider using namespaces, in C++, or Swift modules to avoid naming collisions in your own code. Dependency injection ***. As demonstrated earlier, designing components with dependency injection makes them more flexible and less prone to conflicts. In summary ***. Dealing with path conflicts requires careful analysis and a systematic approach. The best solutions involve modifying the conflicting libraries themselves, if possible, to avoid embedding redundant dependencies. If that's not feasible, consider module mapping, header search path manipulation, with caution, or, as a last resort, renaming. Always prioritize strategies that are maintainable and robust, especially when working with third-party frameworks. Remember that modifying frameworks directly is generally a bad practice, and you should strive for solutions that minimize the impact on the framework's integrity and update process. The example of the hypothetical angle-based Apple developer forums and the reachability library serves to illustrate the common issues and techniques involved.